In 1941, as the war in Europe entered its most brutal phase, the United States had not yet fully plunged into World War II. But what was happening in the skies over? Britain had already signaled an urgent need that the U.S. Army Air Forces would sooner or later have to confront: the need for a fighter that could escort bombers at high altitude, penetrate deep into German territory, and return safely. At that moment, the P-51 Mustang, the aircraft many hoped would become the icon of American fighters, contained only potential, not the capability required for that vital role. The problem didn't lie in its aerodynamics, which were praised as exceptional from the very first test flight, but in the heart of the aircraft. The Allison V1710 engine. At low altitude, the Mustang was powerful, agile, and impressive. But once it climbed above 15,000 to 20,000 feet, where the air thinned and temperatures dropped sharply, the Allison simply couldn't breathe. Its single-stage supercharger wasn't optimized to maintain manifold pressure when the air grew too thin, causing its power to fall off a cliff. At 25,000 feet, where B-17 bomber formations routinely operated, and where German Messerschmitts and Focke-Wulfs patrolled as if it were their private domain, the Mustang was nearly stripped of its fighting capability. By 30,000 feet, the American fighter had become little more than a drifting target. The U.S. Army Air Forces knew this weakness well. They loved the P-51, but they couldn't use it where it was most needed. Meanwhile, the European battlefield demanded exactly what the Mustang could not yet provide: escorts for the giant flying fortresses that were being torn apart day after day by enemy fire. The strategic bombing campaign against Nazi Germany was sliding into a state of crisis. The B-17 flying fortress could carry bombs deep into Germany's factories, oil depots, airfields, and industrial centers, but it could not defend itself against the coordinated, calculated, and increasingly daring attacks of the Luftwaffe. Missions such as the Schweinfurt and Regensburg raids seared the name of the U.S. Army Air Forces with grim statistics. Dozens of bombers shot down in a single day, hundreds of pilots and gunners killed or captured. The Germans, seasoned and experienced, understood the early American and British escort fighters' Achilles' heel. All they needed to do was climb higher where the Allison gasped for Iran, dive down from an energy advantage. The Mustang couldn't climb fast enough, couldn't keep up, and couldn't protect the bomber formations. A superb fighter shackled to a narrow altitude, and this was the painful reality, choking the P-51's potential. But the issue wasn't just aerodynamic or tactical. It was pure physics. How do you supply enough oxygen and pressure to the combustion chamber at altitudes where thin air starves the engine? Rolls-Royce in Britain had already answered that question with the Merlin, an engine equipped with a two-speed supercharger that allowed the Spitfire and Hurricane to climb to great heights during the Battle of Britain. The Merlin was a masterpiece of engineering, but one assembled by hands so meticulously skilled it bordered on obsessive craft. 14,000 individual parts, many of which had to be fitted by a craftsman during assembly. Every bolt used Britain's unique 55-degree Whitworth thread, compatible with nothing made in American industry. Every tolerance in the Rolls-Royce design was written in a just-as-needed manner, never intended for mass production lines. The Merlin was a work of art, not an industrial product, and that was its greatest obstacle. The U.S. military knew that if the Mustang were equipped with the Merlin, it could transform the entire aerial war. But that would matter only if the United States could produce the Merlin in huge, steady, and extremely rapid quantities. Britain bombed daily, operating factories under dangerous conditions and with dwindling manpower could not meet the demand. Rolls-Royce was producing about 200 engines per week. Thus, an impossible mission was born: convert an engine built by painstaking manual craftsmanship into one that could be manufactured on an industrial line with absolute precision using American technology. Do so without changing the size, tolerances, materials, or anything that might compromise its performance. This was not a manufacturing task. It was a translation task between two completely different engineering cultures. On one side, Britain, a world of mechanical tradition, where craftsmen determine perfection. On the other, Detroit, the capital of mass production, where machines and process control defined quality. The Merlin had to retain its British DNA yet be reborn in the spirit of American industrialism. It was a challenge so immense that many British engineers believed it could not be done, even within the engineering community. Converting a handmade product into a mass-produced one while maintaining perfect compatibility was virtually unheard of. But war permitted no hesitation. And that was when the Packard Motor Car Company stepped into history. They had no idea they were about to face one of the most complex engineering puzzles of the 20th century, transforming the Merlin from a handcrafted masterpiece into a mass-production marvel without losing its soul. Every chapter that followed was born from the Mustang's failure at altitude and the life or death needs of thousands of American airmen. The Mustang needed a new heart. The war needed a new solution, and Packard was forced to do what no one had ever done. When the first reports from Europe reached Washington, confirming that the P-51 be equipped with the Rolls-Royce Merlin engine could completely change the game in the skies, a new problem immediately emerged. Britain could not produce enough engines. Rolls-Royce factories were already stretched to the limit building Merlins for the Spitfire, Mosquito, Lancaster, and countless other strategic aircraft. The British could not sacrifice their own aircraft production just to supply engines to the Americans, but the United States could not afford to keep waiting while its heavy bombers were being shot down day and night. In that moment, the eyes of both the Pentagon and the War Department turned to a single name: Packard Motor Car Company. Packard was not a giant industrial corporation like Ford or General Motors. It was a luxury car manufacturer known for meticulous craftsmanship, precision, and a level of refinement comparable to Swiss watchmaking. In peacetime, Packard symbolized American elegance, quiet, aesthetic, and almost entirely handcrafted. But that was precisely why the military trusted them. If America needed to duplicate one of the most sophisticated aircraft engines in the world, no company was better suited than Packard, where even the bolts on their automobiles were individually numbered to match inspection logs. However, copying the Merlin was anything but simple. The Merlin was a masterpiece of British engine, built with numerous rare alloys, and demanding manufacturing processes so precise that even a deviation of a few thousandths of a millimeter could cause vibration or imbalance. The British understood this clearly and initially doubted that the Americans could produce the Merlin at the same quality, let alone improve it. But Packard approached the problem differently. They didn't just want to duplicate it. They wanted to standardize it and enhance it. In September 1940, Packard representatives traveled to Britain to examine the Merlin's technical documentation. The design files were practically a mechanical labyrinth, handwritten notes from Rolls-Royce engineers, hundreds of detailed calculations, and drawings that only their creators fully understood. Translating all of this into the American measurement system alone was a major challenge. But instead of being intimidated, the Packard engineering team received it with an almost serene confidence. They were accustomed to dealing with highly complex mechanisms, from limousine engines to high-speed marine drive systems. They knew that any machine, no matter how intricate, could be mastered if analyzed correctly. A top-secret program was launched in Detroit. Packard transformed its entire factory floor into a military-grade production facility. Rolls-Royce sent engineers along with sample parts, bolts, and proprietary alloys. Both sides worked tirelessly. Rolls-Royce shared everything they had. Packard translated it all into American industrial processes, and then Americanized it with a level of speed and volume Britain could never match. The first thing Packard realized was that Rolls-Royce Merlins were built almost like handcrafted instruments. Each engine differed slightly. Each engineer had unique methods. This ensured high quality but was completely incompatible with American-style mass production. So Packard did something the British had never attempted. They standardized the Merlin into an industrial manufacturable system. Every component was dimensioned using precision instruments. Every assembly step was codified into a controlled process. The blueprints were redrawn from scratch, accurate down to the thousandth of an inch. Many parts that Rolls-Royce once made by hand, Packard now produced with presses, lathes, and automated forgeston. Times faster, yet just as precise. This process was not mere duplication, it was the rebirth of the Merlin. Packard added improvements to increase durability and service life, changed materials in high wear areas, and redesigned certain parts for easier maintenance. Some Rolls-Royce engineers initially worried that the Americans would ruin their beloved creation. But when Packard's test engine roared to life for the first time, their concerns vanished. The Packard-built Merlin 1650 didn't just run smoothly, it ran more consistently than the original. Testing continued relentlessly. Each week, Packard refined another component. A redesigned fuel pump, compatible with American 100/130ths. A reinforced crankshaft to withstand higher RPM. An optimized cooling system capable of functioning in the frigid air at 30,000 feet. All of this transformed the Packard Merlin into an engine not only suitable for the Spitfire or Mosquito, but ideal for an American long-range fighter. When the production line finally began its trial run, Detroit shook with the sound of metal stamping and newly born engines crackling to life. Packard could produce hundreds and eventually thousands of engines each month, something Rolls-Royce could never hope to achieve under wartime conditions. At that moment, a new future opened. The United States not only had the Merlin to upgrade the P-51, they had a mass-produced American standard Merlin capable of pushing American fighters far beyond their rivals. But that was only half the story. The other half lay elsewhere, where another company was preparing to turn the Merlin into the heart of the most formidable fighter the U.S. Army Air Forces would ever field, North American aviation. And when all three P's is Rolls-Royce, Packard and North American finally came together. History was about to change direction. When the Packard Merlin 1650 engine finally reached its completed form, the next question arose. How could this sophisticated machine be integrated into the airframe of the P-51 without losing any of its superior qualities? The Merlin was the pride of British engineering, but the P-51 was the product of American design, powerful, optimized for speed and mass production. To merge these two creations, born from two different engineering cultures, the Americans had to solve a difficult problem. Americanize the Merlin, but without stripping it of its soul. North American Aviation, the manufacturer of the P-51, entered the stage at this moment. They were not simply receiving a new engine. They were receiving a heart with a will of its own, born to work with the Spitfire's wing and the Royal Air Force's style of turn fighting. Installing it into the P-51, a long-bodied, swept-wing fighter with a low center of gravity and aerodynamics, optimized for long-range missions, demanded a level of integration that broke every conventional mold. The first thing North American had to modify was the air intake system. The original Merlin was designed to draw air from a chin intake, while the P-51 featured a unique scoop integrated into the long ventral radiator duct, a distinctive aerodynamic structure that produced additional thrust at high speeds. To adapt the Merlin to this design, American engineers had to recalculate the entire airflow entering the two-stage supercharger of the Packard. Even a slight deviation in the ratio of airflow, pressure, or temperature could reduce efficiency or cause premature detonation at high RPM. Next came the cooling system. The Merlin ran at extremely high temperatures. Rolls-Royce designed it with the Spitfire's dual-wing mounted radiators. But the P-51 used a single, unified duct that combined coolant radiators, oil coolers, and the air intake. The Americans could not alter this aerodynamic structure to very soul of the Mustang, so they were forced to redesign the Merlin's cooling behavior instead. Coolant flow valves were recalibrated. The third adjustment, and the most crucial, was the Merlin Packard's two-speed, two-stage super. This was the component that allowed the Merlin to outperform all earlier Allison engines. But North American knew the engine would have to run continuously 4 hours during escort operations, something the Spitfire almost never did. Tere fuori. But the supercharger's gearshift mechanism had to be tuned so it could smoothly transition between boost stages at optimal altitudes, without jolts or drops in power. This calibration process lasted months, including simulations of pressure changes at every meter of altitude. The result: the Packard Merlin could sustain high power output at heights where Japanese and German engines were already gasping for air. But Americanization extended beyond internal mechanics. It also involved how the P-51 used American fuel, while Rolls-Royce Merlins typically ran on British 100-octane aviation fuel. The United States mass-produced 150-octane gasoline thanks to its enormous petrochemical industry. This fuel allowed higher boost pressure and greater power without detonation. Packard and North American immediately seized that advantage, retuning ignition timing, raising compression values, and adjusting fuel delivery for each flight regime. The result was a Merlin in the P-51B C, and P-51D that produced significantly more power than the Merlin and the Spitfire. MKX something the British couldn't help but envy. Another issue, seemingly small but vitally important, was that the P-51's airframe vibrated far less than the Spitfires. This allowed the Merlin to run at higher RPM without harmful resonance. North American analyzed fuselage vibration patterns and redesigned the engine mounts, using American-made elastic alloys that held the engine firmly yet flexibly enough to absorb high-speed shock loads. Thanks to these, the P-51 could accelerate aggressively without the engine shaking loose, a problem seen in some European fighters. When all the adjustments were complete, something unexpected happened. The Merlin performed better in the P-51 than it did in the Spit, paradox that even Rolls-Royce engineers had to acknowledge. Cleaner, straighter airflow, a more efficient cooling system, greater fuel capacity, a more stable airframe, and higher cruise speed all made the engine feel almost as if it had been created specifically for this American aircraft. This did not strip the Merlin of its British character. Instead, it elevated, it refined. By American industrial science, looking deeper, the Americanization of the Merlin represented something far greater than engineering. It was proof of a philosophy, the fusion of European craftsmanship and American industrial scale. Rolls-Royce could not produce enough engines to win the war. America could mass-produce, but lacked a world-class design. When the two forces converged, the Packard Merlin became a phenomenon: powerful, durable, easy to service, easy to manufacture, and adaptable to every battlefield condition. And when the P-51 finally received the Packard Merlin, a miracle happened. A fighter once dismissed as too weak for high altitude became the Luftwaffe's nightmare. Fast, high climbing, with enough range to escort B-17s beyond Berlin and return safely, yet maneuverable enough to survive engagements with the Bf-109 and FW-190. The P-51 was reborn. But the root of that transformation lay in the fact that the Americans did not change the Merlin SL, they elevated it through science and industry. The P-51 was not just an airplane, it was the story of a rare harmony in aviation history. British spirit, American engineering power, and a design philosophy built for strategy. And this was only the beginning of the next chapter, where the Merlin and the P-51 would finally enter the skies over Europe and become the duo that turned the war's momentum. When the Packard Merlin was finally perfected, and the first P-51 test airframes equipped with the new engine produced results far beyond all expectations, the United States immediately moved on to the most critical phase. Mass production. A brilliant airplane alone could not change the course of the war. Only when thousands of them filled the skies over Europe would the balance of power tilt decisively toward the Allies, and America, with its immense industrial capacity, with Detroit, Dallas, Inglewood, Buffalo, and dozens of satellite factories, was the only nation capable of transforming that vision into reality. At North American Aviation's plant in Inglewood, California, the shift bell rang before dawn. Assembly lines hundreds of meters long glowed under industrial lights. Workers pushed alloy wing frames into position. Engineers installed each transmission assembly into the fuselage, and welders masked and steady created arcs of blue-white fire hot enough to make anyone flinch. Every few hours, a new Mustang rolled off the line. At first, just a bare skeleton, then a winged frame, then a cockpit, an electrical system. And finally, the Packard Merlin 1652-3 lowered into place. Like a heart settling into the chest it was always meant to inhabit. Labor was stretched to every available hour. Women made up nearly half the assembly force. Those who once worked domestic sewing machines now held rivet guns, hammering thousands of flawless fasteners with the precision of a clockmaker. None of them were aerospace engineers, but they all understood one thing. Every Mustang leaving the line meant a bomber crew would live, a mission would succeed, and the end of the war would draw a little closer. Meanwhile, Packard was accelerating at full speed. Detroit, long accustomed to producing luxury cars at a measured pace, had transformed into a literal war machine. Alloy presses ran day and night. Metal foundries operated at temperatures they had never previously reached. Packard workers labored in 12-hour shifts, eating inside the factories so no time was lost. The Packard Merlin was no longer a Rolls-Royce engine. It had become a product of American mass industry, powerful, consistent, reliable, and available in overwhelming quantity. Thanks to that industrial capability, U.S. Army Air Forces units received new Mustangs in massive batch. The first P-51B and P-51C models arrived, followed by the legendary P-51D with its bubble canopy that offered a full 360-degree view. The canopy change was only one small detail among thousands of improvements introduced as the Mustang entered full-scale production. With every batch, North American adjusted the design based on combat reports, improving the oxygen system, increasing fuel capacity, reinforcing the wings for high-speed dives, even optimizing the shape of external fuel tanks to reduce drag. But the greatest change wasn't happening on the assembly line, it was happening over Europe. When the first P-51B Merlins flew from England in late 1943, every doubt vanished. The Mustang wasn't just good, it was superior to everything else. At 25,000 to 30,000 feet, where the air thinned so much that many German engines began to gasp for breath, the Packard Merlin still roared like a predator inhaling an atmosphere made for itself. It cruised faster than any fighter of the time, consumed fuel at an astonishingly low rate, and possessed such range that it could accompany B-17s from England across the North Sea, and deep into German haven, to Berlin, and still have enough fuel left to chase down and destroy enemy aircraft. German pilots encountering the Mustang for the first time were caught completely off. The FW-190 excelled in dives. The BF-109 climbed well, but the P-51 combined both strengths and had nearly twice the range. If the BF-109 tried to climb, the Mustang could follow. If the FW-190 attempted to twist away, the P-51 retained its momentum and acceleration. The Luftwaffe had long relied on a hit-and-run, disengage, return to base strategy. But the Mustang's enormous range made that tactic useless. They could no longer run. The Mustang would follow to the end, and its ability to escort bombers from start to finish transformed the entire air war. Throughout 1943, B-17s and B-24s were slaughtered on missions into Germany. But once the Mustang joined the formations, loss rates dropped almost immediately. Those once vulnerable bomber streams were suddenly shielded by a squadron of long-legged, unyielding knights who stayed with them from takeoff to landing. Bomber crews gave the Mustang a name, part reverent, part affectionate. Guardian Angels. Mass production turned the Mustang into a mechanical storm, crashing down on the Luftwaffe. Every week, America could deploy dozens of new P-51s to the front, while Germany, crippled by industrial bombings and material shortages, could barely produce 10 to 12 fighters. A week. The Mustang didn't just surpass the enemy in quality, it buried them in quantity. That was the power of American assembly lines. Take European excellence, multiply it by American scale, and pour it onto the battlefield like a flood. And when Mustangs filled the skies from France to Poland, from the North Sea to the Alps, one fact became undeniable. The fighter, conceived in just 102 days, had become the decisive weapon that allowed the Allies to claim mastery of the air. But behind that success lay a deeper truth, one that America itself had barely realized. The Mustang was more than an airplane. It was proof that when science, industry, and determination converged in the right way, a nation could alter the destiny of an entire war. And the final chapter of that story, the Mustang S. Absolute dominance over Europe's skies would come in the next part. When the last guns of World War II faded into the past, the skies over Europe grew strangely quiet. The Mustangs that once tore through the air now rested silently in their hangars, their silver wings reflecting the glow of sunset instead of fire and tracer rounds. But that did not mean their story had ended. On the contrary, it was only when the war stopped that the dual legacy of two industrial worlds, British and American, began to truly unfold. The Merlin engine, born from British ingenuity and perfected by American hands, became the model of an engineering partnership that transcended cultural differences, standards, and even measurement systems. The British brought the craftsman's mindset, refinement, masterful workmanship, and the belief that every engine was a handcrafted creation deserving meticulous care. The Americans brought the industrial mindset, systems, templates, and production lines powerful enough to turn that sophisticated engineering into a mass-producible reality. One side contributed the art of mechanical perfection. The other contributed the science of large-scale manufacturing. When those two philosophies met, the result was the Packard Merlin, a testament that precision and mass production did not have to be enemies. If one knew how to build the bridge between them, the first and most visible legacy of the Packard Merlin was its utter transformation of the air war. The arrival of the P-51 Mustang with the new Merlin beating in its chest crippled the Luftwaffe in just a matter of months. Not because Germany lacked skilled pilots. They still had legends like Hartmann, Barkhorn, and Rowell. Not because they lacked capable fighters. The FW-190 and Bf-109 remained formidable platforms. The problem was that Germany could not overcome an enemy that was both exceptional and omnipresent squadrons of Mustangs that ranged far like ghosts, intercepting, pursuing, escorting, sweeping the skies clean. Berlin, once a site of the fiercest aerial battles, became merely a distant waypoint on bomber escorts thousands of kilometers long. That absolute dominance was proof that the right technology at the right moment can alter an entire national strategy. Yet the deeper legacy lay in what the war did not destroy: the technical standards, lessons in compatibility, and collaborative mindset that the Packard Merlin left for the world. After the war, as aviation entered the jet age, engineers looked back on Packard's work as a treasure trove of systems thinking. From that came international standards, like ISO thread specifications, which replaced the chaos of dozens of incompatible thread types, a direct response to the logistical nightmare exposed by the Merlin program. They realized that when global conflict forces nations to share components, every country using its own standard can cause everything to collapse instantly. Thus, the Merlin's legacy lived not only in its engines, but in the very technical language through which the world would communicate thereafter. For the United States, the impact of the Packard Merlin reached far beyond winning a war. It opened the era of modern aerospace manufacturing: tolerance, control, precision casting, dynamic balance measurement, and above all, the philosophy of absolute repeatability. Every component identical, without requiring an artisan's touch to correct it. This became the foundation for every jet turbine that followed, from General Electric and Pratt & Whitney to the later generations of Rolls-Royce. Every Boeing or Airbus you fly today operates safely, largely because of that philosophy. Put simply, if the Merlin was the father of World War II air power, Packard's engineering was the grandfather of modern aviation itself. But the most beautiful and vibrant legacy appears in places few would expect: museums, air shows, and especially the Reno air races. Here, more than 80 years later, Packard Merlins still scream like they did in formation over Europe. Tuned, overboosted, fitted with new pistons and combustion chambers. They often reach 3,800 horsepower, numbers wartime engineers would never have believed. People describe the sound of a Merlin as metallic singing, sharp yet smooth, powerful yet nostalgic. And when a P-51 twists into a high-speed turn, white vapor curling from its wingtips, as the engine tears open the quiet air, people understand machinery at its peak becomes art. Still, no discussion of legacy is complete without acknowledging the human element. The Packard Merlin was not just the product of factories, but of thousands of engineers, machinists, mechanics, and test pilots, people who understood that every bolt, every tolerance, every drawing could determine a pilot's life at the front. A perfect engine is not built solely from materials, but from the spirit of those who create it. When Rolls-Royce saw Packard's improved bearing alloys and later adopted them in their own Merlin, it became the clearest example of collaboration transcending borders. Viewed more broadly, the final legacy of the Packard Merlin is the lesson that civilization advances not through isolation, but through the merging of different kinds of knowledge. The British excelled at creating the exquisite. The Americans excelled at creating systems that spread the exquisite across the world. And in the most chaotic moment of modern history, those two streams of knowledge became one, producing an engine that reshaped the war. Today, when a P-51 Mustang takes off at an air show, people instinctively look up, not because it is the fastest plane, nor the most powerful, but because the sound of a Merlin echoes like a reminder that what humanity achieves through cooperation always surpasses what it can do alone. People don't just see a fighter. They see a chapter of human history where Derby's finesse met Detroit's precision, where art met industry, where war unintentionally created a symbol of peace. That dual legacy of British and American lives on to this day. Not in military stockpiles, but in every gearbox, every jet turbine, every technical standard, every airliner carrying people across the world, and every time a Merlin roars, even for a brief display, it whispers a truth. Sometimes the force that changes history isn't who has more guns, but who understands how to combine their knowledge to create something the world has never seen before.